Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Dede Dermawan and my partner Diken Damara. We are from PJB. I personally work in head office and Diken works in Gresik Power Plant. Firstly, we thank to PJB Connect 2020 because we have such a great opportunity to share our study, especially in Gresik Power Plant. Today, we would like to present our research with the title Emission Dispersion Modeling of Gresik Power Plant using Gaussian Analysis to evaluate environmental impacts in receptor points. This is our agenda today. First one will talk about introduction, the need of air emission modeling, and then second one will talk about theory approach, and then next by method, how model calculation, and then result and discussion, result of the model, and then the last one, conclusion part. What is air pollution? Air pollution is the presence of harmful pollutant in air in quantities large enough to produce dangerous impacts. PJB Gresik Power Plant in its activities produce air emission resulting in from combustion of gas. The environmental team in Gresik Power Plant has routinely monitored ambient air and air emissions. Emission air monitoring is carried out in each chimney, while ambient air is carried out in communities surrounding the plant site. However, this manual monitoring is only done every semester, which does not give an overall picture of the distribution of pollutants in power plant area, especially for ambient air. In contrast to air emissions monitoring, each chimney is equipped with a continuous emission monitoring system or CHEMS that can measure pollutant levels every day. And then ambient air monitoring is a crucial activity to determine whether there is pollution in the community around the plant site. Ambient air monitoring every semester is not adequate to determine the presence of pollution because at the time of monitoring, the condition of the plant may not be operating optimally, so that the results obtained also do not fully reflect the environmental conditions. However, the company is not possible to do manual monitoring every day because it requires large costs. The limitation for conducting daily ambient air monitoring can be overcome by environmental modeling, namely the Gaussian plum model. Gaussian model is an analysis of the distribution of air pollutants from a pollutant source so that it can be estimated the impact that might occur. This model is a mathematical model that is used to present the process of dispersed pollutants in the air, especially from point sources, in this case the chimney. In this paper, we only take a chimney of HRSG 21 as a sample. It can be estimated the concentration of pollutants at various points based on meteorological conditions in the area around the plant. Furthermore, a pollutant distribution contour can be made through mapping using a server device. Now we are moving to theory approach. There are three substantial parameters that influence the pollutant dispersion. The first one is atmospheric stability. It depends on wind direction, ambient temperature, and wind velocity. And the second one is topographical effect. It affects the local wind patterns. An example is the onshore and offshore wind, and another example is the heat island over large urban areas. And then the last one is atmosphere temperature. Temperature change with altitude has huge effect on the motion of air pollutants. For instance, inversion conditions produce only limited vertical mixing. The amount of turbulence available to diffuse pollutants is also a purpose of the temperature profile. Now we'll talk about method. First one, we need to have the data of wind velocity and direction. Pollutant dispersion depends on the mean wind and atmospheric turbulence. Analysis of wind velocity and direction using wind loss plot software to determine atmospheric class condition. Wind velocity and direction data were taken from July to September 2019 from BMKG data. After that, we can use Gaussian analysis. The schematic process is indicated in the picture on the slide, where the origin of coordinate system is at the base of stack, with the x-axis aligned in the downwind direction. The contaminated gas stream is appear rising from the gas tank and then leveling off to travel in the X direction and spreading in Y and Z as it travels. The calculation of concentration dispersion in ground receptor point using Gaussian plumb equation you can see on the slide, where C is pollutant concentration, and then K is emission rate, sigma Y is horizontal spreading coefficient, and then sigma Z is vertical spreading coefficient, and then U is wind velocity. H is stack height plus plumb rise. And then we need to calculate of plumb rise using Holland's formula to estimate the value of delta H. Vs is stack exit velocity, and then D is stack diameter, and then U is wind speed, P is pressure, and then Ts is stack gas temperature. TA is atmospheric temperature. Below there are two tables. On the left, you can see the table which is used to determine the class stabilization. In this paper, the main mean is around 6 meters per second, so we select class C as solar radiation in Gresik is quite strong. While on the right side, the table is used to determine spreading coefficient in urban area. In this paper, we choose class C. The rest of presentation will be delivered Diken.
Okay everyone, I am Diken Damara. I will continue for the next presentation. This is the result and discussions. I will also explain the atmosphere class condition. Before we run the Gaussian modeling, we have to determine the stability categories. As Mr. Dede mentioned before, there are many stability classes to run the Gaussian modeling. And also in our research, we run the windrows in July, August, and September 29. As we can see in the picture, the wind is blue from the southeast into the northwest. This wind direction will specify the direction of pollutant spreading. And the next one. In this research, we also limit the distance of dispersion with the length 2.6 km and the width 2 km from emission source point with 100 meter for level of accuracy. As we can see in the table, this is the parameter that we need to input for calculation of Gaussian modeling. After we run the Gaussian modeling, we can see in the picture that the red zone indicates high level pollution, and the emission from heat recovery steam generator 3.1 or the stack only spreading in power plant area and Pulopancikan village, while Sidokumpul, Kramat Inggil, and Sidoarukun village are not affected by the pollution of the power plant. And the estimation from the Gaussian calculation, we got the data that nitrogen dioxide pollutants exceed the government regulation with about 800 microgram per meter cubic, while the government regulation set the maximum level in 150 micrograms per meter cubic. You can see in September 2019, the pollutant spreading is wider than in July and August 2019. If it occurs continuously, the area is unhealthy for employee, local community, and biodiversity. And the next one, this model can estimate as many as possible. This will strengthen the ambient air monitoring data conducted per semester. And also, this model can be used as a tool to evaluate environmental policy. As you can see in the table, the value of the Gaussian calculation is lower than the laboratory result because there are many parameters affecting the measurement. They are vehicle emission, particulates, meteorological condition, and fugitive emission. Well, and the last one is conclusion. The area around the chimney or the stack in Pulopancikan village were contaminated by high concentration of nitrogen dioxide pollutants. And in contrast, the laboratory results always show well data. This needs to be examined deeply whether the laboratory tests have shown representative condition. Consequently, using only lab tests as a reference in determining the presence or absence of pollution is not adequate. So implementing the Gaussian model can be an alternative to support laboratory data. However, the model in this research has to be developed to obtain better results before being used to evaluate environmental impacts in Gresik Power Plant. Well, thank you for the attention. Goodbye.